Okay, so we are moving into the next portion of the course, the next learning objective. We have Dad. Don't call me Dad. Um, we've finished the program execution learning objective. So this week's lab is going to be on program execution. You have both an interview and a Thursday lab this week. So be aware of that, and that will be similar throughout the rest of the semester. You'll have interviews and Thursday labs. So get ready for that. I've had quite a few students last semester, at least the first one that we did like this. Uh, Let me refresh here. The first one that we did like this, they went to the interview and then skipped the Thursday lab. They thought, well, the interview is the lab. Or they went to the Thursday lab and skipped the interview and said, well, I thought Thursday was the lab. Lab is split into the interview and the Thursday lab. And that'll be the same for most of these weeks. I'm not logged into Piazza, but I did link the Piazza post. It has some information about the lab, and that is where the lab will be posted. We had some confusion last week where I didn't link from the course website to the lab, and students who weren't checking Piazza regularly just didn't know that the lab was even happening. They had legitimate reasons. I think it's reasonable that why they didn't know it existed. They didn't really announce in class where the lab would be posted. But they'll be posted on Piazza. I'll link them from the course website. Like this, I'll link to the Piazza posts when it's relevant. So make sure you're hitting that. Since we've learned everything about program execution that we're learning in this class, this lab is to verify that learning objective. Remember let me scroll up to the top again here. The code reading is going to be assessed on Thursday through the lab, and you can expect that to be, I'm going to give you a program, here's some code, walk me through the stack and heap. Talk to me, what's going on the stack, what's happening each line. Basically, be the debugger. Be the debugger and step through the program one line at a time and talk to me about the stack and heap. I want to hear all about the stack and heap. Writing programs, you did this through the lecture questions. Those 6 lecture questions, get those done for the write. And then explain. Interview with your TA. They're going to ask you a series of questions, and you're going to have to explain these concepts to them. They'll have specific questions related to these concepts, and you'll have to give them good answers, good meaningful answers about those questions and why they're important to us. Why does it matter? Why do these things matter to us as programmers? What time was an interview last week? So your interview TA is going to contact you. They should have already. If not, they'll contact you today. It'll be a different TA than the TA who interviewed you last week, but they'll contact you with the logistics of how to sign up for an interview. They should send you a Calendly link, and then you can sign up for a time to interview with them, just like we did 2 weeks ago for the interviews. Sign up for a time to interview with them, and then interview with them. The actual time of your interview will be up to their availability, and also when you schedule an interview. If you want to choose when you interview, make sure you're checking that email right away and sign up for an interview slot right away so you can get the interview slot of your choice. If you're not checking that email until, say, Wednesday, it's pretty common for all the interview slots to be taken up. All their Monday and Tuesday slots might have went unused, and then their later in the week slots were taken by students who were on the ball and actually checked their email. So just make sure you're on top of that. And get your interview slot. Don't wait till Wednesday because you might not get an interview slot, and then you gotta go through makeup protocols. There was no interview last week. Do you need to explain the code you did in the lecture questions? Not necessarily. They might ask follow-up questions on that. Last semester I did do a lot of, they just said, how did you solve this lecture question? We have more structure to the interviews this semester. There's specific questions that they're going to ask you. So with that, we're moving into the object-oriented programming portion of the course, OOP. You still didn't get an email, just chill. It's the TAs, not everybody works over the weekend. I didn't do any work this weekend. It felt great, personally. But if you don't have an email by the end of the day, contact me. Contact the TAs. Contact somebody. So object-oriented programming. We talked about objects in classes briefly during program execution. We introduced classes and objects mostly because we have to, just to really work with Scala. We need these concepts. Object-oriented programming is going to dive way deeper into objects and classes and talk about the interesting things we can do with them. Now that we are defining our own classes and creating objects of our own types, then what can we do with that, and why? Why do we even want to? So our learning objectives, I won't read all these to you, but you can get an idea of what's coming ahead. The big ones are inheritance and polymorphism. Today we're talking about inheritance. Wednesday, polymorphism. And then the other 4 lectures are applications and implications of using inheritance and polymorphism. And with that, let's jump into some inheritance. And a live rainbow. Hope that's, I hope you're not serious, but, if you are, seek help, please. I hope you're not serious. Oh, that's just joking, but if it's not, seek help, please. And to say that, just, I don't want to assume it's a joke, and then, oops, not at all what I wanted. If you're feeling super stressed out about this class, maybe just set it aside for a day. Do what I did over the weekend. Just take a day or two and don't think about computer science for a while. Meat loves CSE, but Solidify, come on, man. Also, we have 15 TAs. If you really think, that's really your opinion, the problem's probably with you. Inheritance, let's talk about it. Oh my god, my brain, we haven't even started yet. For frick's sake, man. Alright, inheritance. Let's talk about some content. So today's lecture question is similar to last Friday's lecture question with the batteries. Right off the bat, there's no testing requirement for this one. You don't have to write unit tests. The concept of inheritance here is tested in writing your code, so I don't really have to test your test writing abilities, but that will come into play, shortly. Most lecture questions are going to have testing. This one doesn't, just because I want to get the idea of an abstract class and extending that abstract class. So instead of just creating the flashlight class, create an electronic class with similar functionality to the flashlight, a state variable named battery, but not set in the constructor, methods named use and replace battery that do what you expect them to do from the flashlight, except they're not, except use is not defined in this class, in this electronic class. Flashlight and another class, boombox, are going to extend electronic, so they're going to grab all this functionality and then implement anything that's not implemented, like flashlights coming with batteries included. Create a new battery with charge 5 when it's created. The use method, just like you saw on Friday. And then boombox, which does not come with batteries included. You have to provide the batteries in its constructor call and then pass that battery to the electronic constructor. And using a boombox reduces the charge by 3 as long as you have enough charge to actually use it. So let's talk about these new words: abstract class, inheritance, extends, and how to use them in our codes, in our programs. So I'll show this image again at the end of lecture, and it'll make more sense at that point. But this is the type hierarchy, at least a very small subset of the type hierarchy in Scala. This is how classes relate to each other, and these arrows mean that this class extends another class, which is a word we have yet to define. For now, we have everything extends any, and we have 2 different types, either any val or any ref. Any val is everything that I've been calling primitive types. These all go on the stack unless they're part of an object, of another object that's on the heap already. These are all going to go on the stack if they're declared within a stack frame and not in a class. And any ref, this is everything that's going to go on the heap, which includes every single class that we write. And also some common ones that we use: list, map, array. Everything that's not one of these. Everything that's not one of these going on the heap. So what does that actually mean? So let's set up an example, a problem that we want to work on, and build some functionality of a game. We probably won't actually build this full game. I used this example last semester and still haven't built an actual game out of this, so it might never actually exist. But let's conceive this game that we want to build and build some of the core functionality of it. So we want a game where players have two attributes, health and strength. Players can run around the game and pick up and throw balls. And if a ball hits a player, they're going to lose health according to that ball's weight. You can also collect health potions to regain some of your health back. So it's basically a dodgeball game with health potions added to it. So this is the game we want to talk about. Let's talk about how we would build this thing. Dodgeball, but health. And health potions, a way to regain some health. So let's talk about the different objects we need in this game. Player, ball, health potion, basically the nouns from the description of the previous slide. So we have these objects that we want to create. And let's create them. Let's see some code and build them. And I should mention explicitly, this is reviewing objects and classes for now, just to make sure everybody has the right background. And then we're going to dive into inheritance and OOP proper. So when we were working with objects, we would create an object of type player, a player object, and then put all of our code in here. We have some methods for its behavior, and we have some variables for its state. And we want to know certain things about the player, its location, how large is the player, how large should we render the player's sprite, and we need that to determine if a ball actually collides with the player or not. Player's velocity, including direction, is a vector, and orientation. Which way is the player facing? So they might be facing one way, but their velocity is another way because they're strafing or whatnot, whatever way they're looking. And we want to use the orientation for what they throw a ball. They're going to throw it according to their orientation, not according to their velocity. So some things like that, variables we want to keep track of. Most of that's fairly arbitrary. We could set this up in different ways if we wanted. But just for example, these are the variables, the vectors that I'm going to store to represent the exact state of a player. Also, max health, current health, and their strength. How hard can they throw a ball? And health, self-explanatory. Health, how close are they to dying? And max health, if they use a potion, what's the maximum amount that they can heal up to? So that's our player object. All the state can change as they play the game. All these variables are going to have different values as they move, as they get hit, as they drink health potions, etc. And the methods, when they use a ball, what's going to happen? We're going to defer to the ball class, ball object that we're going to write, and the potion object that we're going to write for the behavior of these. The ball object, similar, location, dimensions, and velocity. We don't care about orientation. Ball's orientation, we can just assume is its same as its velocity if we even care about such a thing. And its mass, to determine how much damage it's going to do. And when a player uses this, we're going to take the player's strength and orientation and determine how what these values are going to be set to, specifically its velocity. Which direction is it going to be, is it going to face? Autolab error. Well, you haven't had the lecture yet, but so I would guess that's an error on your end. My solution had full credit, which I always test before lecture. And finally, health potion. Again, location, dimensions, velocity, in case you want to throw a health potion for whatever reason. And volume, which we're going to use to determine how much it can heal. We're going to say whatever the volume is, that's how much healing power this potion has. So when a potion is used by a player, we're going to give a reference to the player to this method. And then that player's health is going to be its health plus volume, and then take the minimum of that and the max health of the player. So they can heal the amount of volume only up to their maximum health. And I'm using min. I could do math.min and give that to these two arguments. I decided to use the min method, which is part of the int class, just something we can do in Scala. Just something a little cleaner syntax. Sometimes I have, for what it's worth, like 4 less characters. But just a different way to call the min method. I'm calling it through the int class. So we have these 3 objects. Glass bottle is going to do less damage than a snowball. I don't know how to answer that, man. I gotta check some real quick. Player.health is the health of the player. So the player has some health, and if health reaches 0, they're out of the game. Min takes the minimum of 2 values, but I called it differently. I called it from an int. So this is going to resolve to an int, and the int class actually has a min method attached to it as part of its behavior. So I'm calling the min method from the int class, giving it another int, and this is going to return the minimum of the 2 ints. So if I heal up to 19 and my max health is 20, my health is now 19. If I'm currently 19 and I heal 3 up to 22 and my max health is 20, it's going to return 20 because I can't exceed my max health. Error while grading lecture question. Yeah, I mean, it means you have some error. You probably have something named wrong. I'm not going to debug your submission during lecture, dude. Maybe I can. I probably won't have time, but double check the question and make sure you did everything right. You clearly only spent 7 minutes on it because I just uploaded the revised slides. So come on, at least give it a try before you interrupt lecture with that. So we have these 3 objects, and really don't interrupt lecture with debugging questions. The lecture questions during lecture should be related to what I'm talking about in lecture. Please, I mean, come on. Most of the time I'll ignore it, but this one, P, you talk a lot during lecture, and some of it is good questions, so I want to make sure you know. Tone it down a bit. Keep it related. So we have these 3 objects: player, ball, and class. But this game is pretty boring. Depending on your opinion, it might be boring no matter what we do. But it's very restrictive when we use objects because we can only have one of each of these. We have 1 player object, we have 1 ball object, and 1 health potion object. And that's it. That's it. All we can use in this game. So we can play it. We can have 1 player. Dodgeball without multiplayer is going to suck. It's going to be boring. And they can only interact with 1 ball and 1 health potion, just 2 objects. This is why we use classes. So instead of defining these as objects, we define these as classes because we want multiple objects of these types. We want more than 1 player. We want a multiplayer game. We want more than 1 ball object. We want more than 1 health potion object. So we can interact with multiple objects of these types. So when we define a ball class, now we can say new ball, new ball, new ball. Give me 3 balls for this game, and then let the players throw those around, and get multiple objects of that type. So why? Yeah, good question. Why not always use classes? I'd say most of the time we lean towards classes, but if there's something that you'll only ever want 1 of, maybe you're writing a web server. The server, instead of a server class, you could create server object if you know it's only ever going to be 1 server. For the referee in the lecture question last week, we only had 1 referee that officiated every single game, so we created that as an object. A more concrete example is the math. The math, it's technically a class because it uses Java stuff, but it uses static classes, which are like Scala objects. We would create math as an object because we're using it as a library of methods. There's only behavior and no state. It's just a collection of methods. So math could be an object because there's no reason to have multiple math objects in our code. We don't ever say new math.abs or whatever. We just say math.abs from the object. But you should favor classes. Usually every type that you create is going to be a class, unless you absolutely know you're always only going to want 1 of them. Then you could create it as an object. But there's really no real advantage to creating a class instead of an object, except you don't have to type new, I guess. Is an object made from a class still called an object? Yeah, in fact, they're the same thing. So when I said object health potion, that health potion is the same thing as creating a class health potion and saying new health potion. They behave exactly the same, except when it's an object, I refer to it as the object name, health potion dot. When I create new health potions from the class, I can store a reference to that that object in a variable with any name that I want. But they behave exactly the same. If I created a math class and created new instances of the math class, they would behave exactly the same as if I did math dot my methods. So this is why we use classes, multiple objects of the same type. Can we have multiple objects in a class? It depends what you mean by that. We do have multiple physics vector objects inside these classes. So if that's what you mean, absolutely. If you, not sure what else you could mean there. If you want to clarify, I'll give it another shot at answering that. Cool. Nice. Glad to hear it, Bite. So let's take a look at the code for these. So now things get a little different. With objects, not too different, but this is stuff we already saw, but just to reinforce it. With objects, we'll never have a constructor. There's never a constructor in an object because you only have one of them. You're not using the object to create new things. But with a class, we are. So with a class, we want to use this to create new objects of type player. So in our code elsewhere, we're going to say new player, new variable, whatever, equals new player. And then we call the constructor. We have an argument list, and we call that constructor to create new objects of this type. So when we move to classes, that's where we started talking about constructors. We'll never have a constructor in an object. We will have constructors, always have constructors in a class. That constructor might not take any parameters, but we always will have a method for the constructor. We can have a class in an object. You can. It's called a subclass. But it's not something. It's not something I'll show in this class. It's not something I'll really talk about unless like the 20 minutes after lecture I might sometimes. But it's not something we need to be concerned about yet. There's enough stuff to learn. But you can define classes inside of an object or classes inside of other classes for what it's worth. If you wanted 2 referees, then you would have to define it as a class and then create new objects of that type and say new referee, store it in variables, get a few referees. You wouldn't be able to do that with a class or with an object. You would have to define it as a class. Yeah, OOP is pretty great. So here we have a constructor. We can still declare variables just like we did with objects, where we had variables declared inside the object definition but outside all of the methods. We can still do that with classes, and there are cases where we definitely want to do that. For example, the flashlight, batteries are included. Somewhere outside of the constructor and outside of all the methods, we're going to have to create a new battery with a charge of 5 and assign it to the state variable named battery that's inherited from the electronics class. We haven't gotten into inheritance yet, but we certainly can write code in here still. But anything that we want to initialize to different values for each object that we create, that's where we use the constructor. So we're going to give it define a constructor that takes all of the values that we want to be different or potentially different between different objects in their initial state. So whenever I create a new player, I'm going to say I want to define their location, dimensions, velocity, orientation, max health, and strength. I'm going to say it's possible that all these things could be different for each player in their initial state, and I don't want to say create a new player and then modify these values. I'm going to define them right in the constructor. So whenever somebody creates a new player, they have to give me all of these values to define how it should be initialized. How should this player be initialized? For the rhyming dictionary assignment, we have a class rhyming dictionary that takes the dictionary file name. So when you create a new rhyming dictionary, you have to say, okay, where's the source of all my data? And then initialize the dictionary, parse the file, read all that to be able to get the data loaded into that into an object of type rhyming dictionary. Same thing here. What needs to be initialized in the initial state of objects of this type as they're created? And it's fairly arbitrary. I could say every player has the same max health, strength, and dimensions. Those all certainly make sense. But location, velocity could be zeroed out. That could also be out of the constructor. So some of these choices are up to you as the programmer, what you want to do. But like location, that should definitely be in the constructor. Every player should have a different spawn point. Where are they going to start the game? Probably not all in the same location. It's probably not the behavior you want of your game. Throw that in the constructor. You can initialize it to a different value for every object of type player that you instantiate from this class. If you don't use either var or val in the constructor, it'll default to val. I believe there might be some small difference between val and... Oh, actually, I do know. Between val, if you don't use val or var, it'll default to var, and it also won't be accessible from outside of that class. I'll always use var or val, unless I forget in my lecture slides. But if you don't use either, it's effectively a private variable, and you can't access it outside of the class. Outside of this code here. You wouldn't be able to do player.maxHealth elsewhere in your code if we didn't have val here. So as a rule of thumb, always use val or var in your constructor parameters, at least for this class, unless you are absolutely sure about the behavior you want. Actually, I take that back, because later in this lecture, we're going to create some without val or var. But I'll talk about it when I get there. Yeah, not accessible is a big... and that's one of the things you can do. You could get that error that P was talking about earlier. In this lecture question, if you don't use val or var in your electronic battery variable... does that make sense? No, because that's not in the constructor. But if in one of your constructors you don't use... No, none of the constructors even take anything. Except boombox, and that shouldn't be read by my grader. I guess you can't get tripped up by that in this lecture question. But if you don't use val or var in a variable that I need to read from my grader, you're going to get an error in the auto grader, because I'm trying to read a variable that you are not letting me read. Yeah, because you named it flashlight. Yeah. I made that typo last semester. I fixed that today and Friday for those lecture questions. I accidentally had a capital L in flashlight. Don't be like I was last time when I wrote these questions. Okay, moving on. So ball, same idea. What do we want to initialize? In this case, we're going to say all of its state can be initialized differently for each ball. And the behavior is the same. We didn't change anything there. We just moved the declaration of all our variables to the constructor, got rid of the initial values that we set all these to some defaults when we had this as an object. Now as a class, we're going to throw all those things in the constructor and leave it up to the people of the code that's creating new objects of this type to set all the initial values of these variables. Same thing with health potion. Not much more to say. Same thing. Move all those things to the constructor. Let us create health potions with different location, dimensions, velocity, and volume in our code. You can probably use var all the time until we get to functional programming, where I'm going to ban the keyword var. So just a heads up there if you're getting too used to putting var all the time. Yeah, and it's a good idea. Is me Jukes? It's just a good idea too, as they mentioned, to let your fellow programmers and yourself in the future. I've looked at so much code that I've written and I forget what I was doing. If I have val in that code, I know it's my reminder. Oh, that's not going to change. So if I'm tempted to change it later on, I know I don't do that because I declared it val. Just like const in JavaScript, it tells me that shouldn't change. So don't try to change it. If you're changing it, you're doing something wrong. So now we have these classes. I have this ball class defined like this, and I can create new instances of this. I can create multiple instances, multiple objects of the same type instead of just one of them. So now, new ball, give it the constructor arguments, give it arguments to the constructor. Those are assigned to the parameters, assigned to the state variables, and we create new objects in heap space. We store references of them in our variables, and in heap space we have all that state and the behavior. I didn't talk about the behavior much, but each object is going to know its behavior, and it's going to get that from the class definition, and it's going to remember all of its state. So now I can create multiple instances of this class, multiple objects on the heap with the same type of this class type. That's why we use classes. Multiple objects of a particular type. We define the type through a class, which is like a template to create objects of that type. And then we create objects of that type using the keyword new. New allocates heap space, stores, runs all the initialization, stores all the state of that object, and returns a reference to that object. Ball1 stores a reference which says, where can I find that ball object on the heap? Okay, so that's our review of objects and classes. Hopefully that's crystal clear in everyone's mind. Maybe not crystal clear, but pretty clear on why we use classes, what's the difference between classes and objects. That was all program execution, learning objective 1 material. Well, let's get into, now that we have a nice, slow, easy transition into the new stuff, let's talk about inheritance. So with health potion and ball, we'll notice that there was a lot of common functionality between these. Their state and behavior followed very similar structure. They have the same 3 physics vectors, a little bit difference here, mass or volume, and they both have a use method that takes a player and returns unit. So this is a lot in common. So what can we do to reduce our typing workload, for lack of a better reason here? If we want to lower our typing and lower our duplicate code, which is always just general advice, if you're repeating the same code twice, there's probably a better way to do that. Duplicated code is very bad because if you want to change that code, you have to change it in multiple places. It's easy to forget at least one of the places where you're supposed to change that duplicate code, and then you get bugs, and it's just painful. So we're going to create a third class that's going to factor out all of the common functionality of ball and health potion. That third class is going to store everything that's in common between the two, and then we're going to inherit that third class in each of these 2 classes. So I'm going to create a third class named inanimate object, which is going to store all of the state and behavior that's common between every inanimate object in this game. So balls, health potions, anything that's not a player, well, there's only 3 things, players, balls, and health potions. But if I want to add new inanimate objects, new pickups and new power-ups and stuff, I'm going to use this inanimate object class. Anything that's common for any of those things that could exist in the future, they're going to use this inanimate object class. So inanimate object is going to store the common functionality, location, dimension, velocity vectors. And I'm going to define some more behavior, this object mass. I'm going to say any inanimate object, I need a way to figure out its mass. And then the use method that we already had in both of these. So this inanimate object is going to define all of this state and behavior. And then we're going to inherit. We're going to inherit inanimate object in ball and health potion. And ball and health potion are going to grab all of that functionality from inanimate object and then add whatever extra stuff that they need. Volume for health potions and mass for balls. So when we create a new where's my mouse? It's been bugging me, trying to get out of the way of my slides. So we're going to create a new class with all that behavior, that common behavior, and we're going to define it as an abstract class. So abstract class is kind of, as the name implies, it's an abstract kind of conceptual thing. We're never going to be able to work with the inanimate object class directly. We can't say like new inanimate object because it's just an abstract concept, an idea. It's not something that can actually be created. We can't actually just have an inanimate object And we use this keyword abstract, this abstract class, to say that this class is not fully defined. And you see that in object mass and use, we don't actually have any definitions to these methods. So these are what we call abstract methods. Once a class has at least one abstract method, it has to be an abstract class, because you can't create an instance of a class that doesn't have its behavior fully defined. So this has some behavior half defined, but there's no equals and then method bodies to these things. So these are abstract classes, or abstract methods, which makes this an abstract class. The only way that we can work with this functionality, that we can get all this functionality, is by extending this class and finishing the definition. Define all of these methods that are not fully defined, and finish writing the class, basically. So if we want a ball of type inanimate object, we're going to extend inanimate object and then call the constructor of the inanimate object in the ball class right after its constructor. So we have class ball, its constructor, extends, meaning I want all of the functionality of some other class, extends inanimate object, give me all of the methods, all of the variables from inanimate object in this class, and then you have to also call the other class's constructor right in line in the ball's constructor. And this is, I wish I changed these names. These names, for clarity, I like to have these as different names than the names of the variables in the other constructor, the constructor that I'm extending. These should be different names just for clarity. But if these are the same names, you can only declare one of them with either val or var. So here I'm not using val or var, meaning these are private variables, which means they can't be seen outside of the ball class. But the ball class is extending an inanimate object, meaning it borrows all of it. It gets all the functionality from an inanimate object, which also defines location, dimensions, velocity. So when I type velocity down here, is it this velocity or is it this velocity that I stole from inanimate object? You should name these something different just to avoid the confusion of which variable you're going to access. But we get all of the functionality from an inanimate object, so ball is going to get these variables and these methods. But there's one problem. These methods are not fully defined. So now what we can do, and what we have to do, is override their functionality. We have to define these methods. This object mass, which wasn't defined, we have to define it now. We have to give it a body and say, what does this do? If we don't, then ball also has to be abstract, which means we can't have any balls in our game. We can't create new objects of that type. So we're going to override, meaning I know I got a method from what we call the base class. I know I got, or the super class. I know I got a method from this class that I inherited. Whatever I got from that class, I want to override it with my own code. So I want this object mass method to have the definition that just returns this dot mass. I already have a mass variable. My object mass is just going to be that variable. Then the use method, I want to override that. Whatever definition I got, in this case, no definition at all, I want to override that with this use method, which is the use method from our class that we had before. Why can't you build this into the ball class? So this is the ball class right here. We can, so what we had before, we had all of this functionality without an inanimate object. We just put all this in the ball class. So ball is not really gaining functionality from this. We're going to see why we do things like this in a bit, because right now it just looks like extra work for no benefit. We will see. You'll probably have to wait till Wednesday to get a decently satisfying answer to that, but I will give you some taste of why we do this today. And technically, I don't have to use the word override. Dennis Grace is asking a good question here. I don't really have to use the word override here because I'm not overriding anything. These are abstract methods. So I'm not overriding any behavior, and if you don't have the keyword override here, this will work just the same if we don't have override here and here. I recommend still using override because override is going to tell the compiler, hey, I'm overriding a method that I inherited. So if you have a typo somewhere in this method, if you have this called object mass with one S, for example, and you have the override keyword, the compiler is going to say, hey, you told me you're overriding something, but I didn't find anything over here that matches. I don't know what you're overriding. It's going to give you an error and let you know that you have a typo. If you don't have override and you have a typo, the compiler is not going to be able to help you out because it's like, oh, you must want object mass and object mass with only one S and give you both those methods. One of them is not defined. Your error is going to be ball should be declared abstract, and that's a little harder to debug, especially when you're getting started. It's going to say, hey, you have an abstract method named object mass, and you're going to be like, no, I have object mass. I gave it a definition right here, and it's just tougher to debug. So if you are implementing abstract methods, I still highly recommend writing override just to get that extra protection. It can help your debugging. But you're right that it's optional. If we had a definition here, we would have to use the keyword override. So we can do the same thing in the health potion class, except object mass, we're going to take the volume and say how much mass per volume do we have, and then do a little calculation to come up with the mass. So now this is extra functionality that we didn't have to have before, but since health potion is extending inanimate object, since inanimate object has these definitions, these declarations, object mass and use, any concrete class, which is a class that's not abstract that you can instantiate, you can create objects of these types. Anything that extends inanimate object has a contract to fulfill. It has to implement every abstract method that the abstract class declares. So abstract class, part of this is following this this contract. Object mass, it returns a double. Use takes a player, returns unit. If you're extending an animate object, you have to implement those methods. You have to guarantee it. The compiler will guarantee that you do implement these methods. So in health potion, we got this contract. Well, use is easy because we had that already. But now we have a contract. Object mass, we have to define this. So let's define this by taking the volume and doing some math to figure out what the mass should be given some particular volume. For that. So now we have two concrete classes that both extend an inanimate object and fulfills those contracts, that object mass and use methods. Great, but why did we do this? Why bother? So one of the reasons why we do this, one of the big advantages that we have is when we want to add functionality, add behavior to every inheriting class. So I have balls, I have health potions. They both are objects in my game that should have a lot of similar behavior. And if I want to add functionality to these, I add functionality to both of them by adding functionality to just the base class, or just the superclass, just an animate object. So if I want to compute the momentum of inanimate objects, I put this method in the inanimate object class. I use the object mass method that I have a contract that says everything that extends me has to have an object mass method implemented. I don't care how it's implemented, how you come up with your mass, but everything that extends this has to have a way to compute its mass. Now I can use that fact to call that method, no matter what's extending, whatever that method is, balls or health potions or whatever else, get the mass, call that method, multiply it by the magnitude of velocity, and compute the momentum of any inanimate object. Now, balls and health potions both just automatically have this method, and either of them I can say dot magnitude of momentum and objects of either of those types, and I have access to this functionality. The alternative would be writing this method in one of those classes, cut and pasting it to the other one, and now we have duplicate code, which can be hard to debug. If I want to change the way I compute momentum, that can get tricky because I have to remember every class that behaves that way, and every time I use one of those classes, I have to make sure it's used in the same way. Or I can put it in the abstract class, have it share that functionality, and then just call it done. If I ever want to change this, I mean, bad example since it's momentum. Momentum, the function, the math isn't going to change here. But if I do want to change this or add more to it, I just change it once and it updates everywhere. Also, when I want to start adding even more classes, when I want to add 10 more objects, I start dreaming up all kinds of cool ideas for this game, and I want 10 more inanimate objects of different types. I can just write classes for each one of those, extend inanimate object, and then only focus on the things that are specific to my new ideas. Every time I create one of those, I don't have to be thinking about momentum. I don't have to be thinking about location and dimensions and any of that stuff. I can just think about what's specific about this new object that I'm creating and how does it behave inside the game. Like, what does this thing do in my game? I don't have to be worrying about all the physics and momentum and all that stuff and anything else that we want to put in this inanimate object class. But wait, oh, damn it, slide. Work with me. Yeah, I got ahead of my slide there. But wait, there's more. I can also extend from the abstract class. I can extend another class. In this case, I can extend dynamic object from the physics engine homework. So I can have every inanimate object have all of the functionality of a dynamic object, call dynamic object's constructor, and dynamic object also has a velocity variable that's not initialized through its constructor. So I'm going to add a line here saying this dot velocity, which it got from the dynamic object class, and set it equal to this input velocity, which is properly named differently than the velocity variable in the dynamic object class, which I should have had on the other slides. My apologies. And then set that velocity, this dot velocity, which is from the dynamic object class, equal to initial velocity, and get all of the functionality of the dynamic object class, which means that balls and health potions now work with our physics engine. So all the physics engine code, computing collisions, figuring out which face a collision was on. Bad example because these are all dynamic objects. Finding collisions, updating based on velocity. If we want health potions, balls mostly to be thrown and follow nice parabolic arcs and detect when they hit another player. All of that happens just by extending dynamic object and throwing these things in our physics engine. Physics engine knows what to do with dynamic objects, so there's no extra work for us to do. We just extend dynamic object and we get all of that functionality. So we don't have to rebuild physics for this game. We just use the same physics engine that we built for Jumper, throw it over here by extending dynamic object, throw our objects into the physics engine. Everything's great. Everything works. In this, you can read this, but this dot velocity and the difference between input velocity, the naming, and velocity. So our inheritance tree starts looking like this. We have health potion and ball, which extend inanimate object, which extend dynamic object, which hopefully makes this picture make a lot more sense. We have nothing and null, which we won't use in this class, which extend all of these values. Double extends any val, which extends any. List extends any ref, which extends any. Your class implicitly extends any ref, even if you don't write extends any ref. Your class extends any ref, which extends any. So you get all of the functionality. Whenever you create a class, you get all the functionality from any ref and all the functionality from any. And I'll talk about this next time. That's more polymorphism, just to tease that, but I'm a minute over, so I won't tease it too much. And brings us back to the lecture question. All right, so that's the end of the lecture portion. Let's chat. I saw chat going. A lot of that was TAs just chatting, so I knew I could ignore it. But let's see what we got in here. Yep. So once I have magnitude, let me get one with it in color. Once I have magnitude of momentum, once I add that to an animate object, whenever I have an object of type ball or health potion, without changing any other code, just adding that to an animate object, I can do health potion 1 dot magnitude of momentum and get its magnitude of momentum. They inherit that functionality from the abstract class. And I didn't mention this explicitly in the lecture portion, but abstract classes can have definitions to their methods. Abstract classes don't have to have only abstract methods. Here we have two abstract methods and one what we call concrete method with a full definition of everything that we need in magnitude of momentum. So we have all the functionality we need here. So in our other classes, we don't have to override magnitude of momentum unless we want to, but we don't have to override it because it already has a definition that we inherited. So in health potion, we don't have to say anything about magnitude of momentum. We just get that functionality. No override, nothing involved. If we want health potions to have a different implementation of magnitude of momentum, we could use override still and change the inherited behavior. Override this behavior, which is where the keyword comes from, override this behavior with our own definition of that method for one particular subclass. We can do that also, which we'll do on Wednesday. We'll do some of that. You can override variables as well. I wouldn't. That's why I recommend naming your variables different names in each class. That's why I keep saying that. It's so you can avoid the overrides. You can override variables as well, though. But I find it easier to get yourself in trouble when you're overriding variables, especially when submitting to Autolab. Autolab's going to expect variables to be defined in certain classes and then inherited in other certain classes. If you're overriding variables, you're almost certainly doing that to fix a problem without actually fixing it and then getting errors in Autolab. Usually I see that when students are using the autocorrect. Like, hey, IDE, I have this error. Can you fix it for me? And it'll give you an override for the variables. And then you have no idea what actually happened, and then you get errors in Autolab. So I'd recommend not doing it and actually, looking into what the root cause was. Yeah, you could set equal to defaults in the abstract classes. So dynamic object, I believe, sets its initial velocity to 0, 0, 0, 0. And then we say this dot velocity, that says this dot velocity, which is the variable from the dynamic object class, override its initial value with the input velocity from this constructor that that was received from one of the other classes, one of the inherited classes. What was the this? So this is the keyword that refers to the calling object. I would refer you to Friday's lecture for that one. We talked about this quite a bit. This is it's a keyword that, I'm just repeating myself. Yeah, the calling object. I'm lost in this computer science heaven. Oh, a lot of good answers in there. Nice. Can you extend multiple objects? Kind of. You can use mix-ins in Scala. We're not going to see those till later in the semester. For now, when we want to extend multiple objects, we'll have an inheritance chain like this. We have health potion, extends inanimate object, extends dynamic object. We can chain them together like that. The problem with multiple inheritance is if you extended two classes that both have a definition for either a variable or a method that's the same, which one do you get? Which one does that extending class actually get? You have a conflict. We call it the diamond of death for inheritance, and it can cause a lot of problems. So you can do it, but you can't do it with abstract classes. I'm like 90% sure on this. Abstract classes, but you can do it with traits. which are kind of like abstract classes but more restricted. I believe they can't have a constructor. Is the difference with traits. I'm a little fuzzy on that one, so don't take my word for it 100%. But that's something we'll talk about way later, and only briefly. It's not something we need for 116. Can you address the class itself? No. Like when you create a class, you can't really access anything in that class without creating an object of that type. I believe that's true in general in Scala. You can't do anything with the class. Like in Java, you could create static methods and static variables and access them through the class directly. You don't really do that in Java or in Scala. In Scala, you want to do that, you would create an object of that type. So you can create a class with a type and also create an object of that type. So if there's anything you want to access at the class level, you would go to its corresponding object with the same name. But again, we're not doing that quite yet either. I'd be happy to show you some of that stuff, but we're just not going to have time. We'll see that a little bit. I believe with web servers, or no, with GUIs, maybe both. We actually set things up like that with a class and an object with the same type. Yeah, multiple traits. Thanks, P. So confused right now. I mean, if you have a question, that would be more helpful. Just stating you're confused, like I'm getting that a bit in chat too. Like just stating you're confused doesn't help anybody. If you ask what you're confused about, like we can help. There are TAs in chat, and I'm reading chat too. Like, let us know what's confusing you. And come to office hours. Yeah, and yes, Night Sniper has a good point here. You're always gonna be confused. Like when I first learned about classes and objects too, it's new stuff. It's gonna take a while to sink in. I've said this before, worth repeating. If you can understand, if you went through that lecture, you watched that lecture, and you're like, I understand inheritance now, you're an all-star. Like that's not the expectation. The lecture should be your first introduction. Then you get your hands on the lecture question. You start working through that. You refer back to the slides. You re-watch the video. Go to office hours if you have questions. Post on Piazza. Like it should take some work before you understand inheritance. You can't just watch this lecture and be like, oh yeah, I get it. You should feel a little confused during lectures. I mean, not that that's the goal, obviously, but these are pretty deep concepts, pretty in-depth technical concepts. Yeah, and Wednesday's polymorphism. So polymorphism, in my opinion, like inheritance, I motivated it with a few little things today, but really the big payoff is polymorphism. For me, that's the reason to use inheritance. The things I said here, factoring out common functionality and extending that and creating multiple subclasses of the same type, that's all fun and good, but it's somewhat pointless until you start using polymorphism. Then it really gets powerful. Like extending dynamic object, that actually doesn't give us anything that we want until we start talking about polymorphism and why that's important. Polymorphism means that we can use, which I'm motivating on this slide, that we can store variables of one type in variables of different types. So since health potion extends inanimate object, which extends dynamic object, which extends game object, which is in the physics engine, which extends any ref, which extends any, we can store health potions in variables of any of these types, which means we can store health potions in data structures that store any of these types. So if we store health potions, balls, players, everything mixed in with all these different types into one list of type dynamic object, then we give that list of dynamic objects to a game world, give that to our physics engine, and now we can update locations of all of those because they all follow the dynamic object class, all the guarantees in there. Specifically that they have velocity, dimensions, location, and then collisions can be detected with that data. Hi, Night Sniper. you go back and explain how velocity dot this dot velocity dot x knows how to choose between the class constructor and the extended class? Yeah, so Ellipso, that's where I wish I updated these slides to have different names. But that's where I say have different names between your classes. So like when I have balls constructor, I should have named this like input location, input dimensions, input velocity, and then gave those to the inanimate objects. So now down here when I say this dot velocity, then I know it's getting the velocity variable from inanimate object. If I do it the way I have it set up here, is it accessing this variable or is it going to the inherited inanimate object variable? There's no good way of knowing. I think this might even give us errors. I think I'd have to double check that. If we have some time, I can go into IntelliJ. But it's a big question. So I would always name these variables different names than the names that you inherited from the inanimate object class. These three variables. These three names are already taken. Don't reuse those names. And then you don't have to worry about that. Then you don't have to worry about questions like that. So can't figure out the replace battery method. Yeah, it's that one I nerfed it a bit this semester, but yeah, it's still. Put this over here. It's still a tricky one. It really tests your understanding of references. You really have to understand what references are doing on the heap, which is why I really like that question, which is why I didn't scrap it completely. But you got to understand references to know how to test that method. Just make sure you're testing the reference of the battery that's inside the flashlight after replace battery was called, and also the reference of the battery that was returned from the replace battery method. Check that those references are referring to the same batteries, the batteries that you expect them to refer to. Get to work. How long for the rhyming dictionary? I mean, on the order of seconds. Maybe 5 seconds. So when you submit to AutoLab, it's actually going to take a while because the dictionary has to be parsed so many times for each test case, for each of the lab tests. So the dictionary is being parsed a lot just for each test on each sample program. So it does take a while to grade, but when you're running locally, like 5 seconds, 5 to 15-ish, it shouldn't be on the order of minutes. Unlimited charge, it's letting the charge go negative. So you can still use the thing, even with no charge left. So use the battery, use the flashlight 6 times with a new battery without replacing it, and it actually works on that 6th time. It decrements the charge. Oh, hey, good answers in here. Oh, this is a good example. Like, students are always afraid that, and this is maybe a little borderline about academic integrity. This is what I'm talking about is I would be okay with. It's maybe this is a little too direct, but since you're not sharing code, you're talking about the abstract of this. Use the flashlight 6 times. Like to actually use that advice in your code, you actually have to understand what that's doing, which takes some understanding of what's going on in the course. So I'm fine with that. Maybe a little borderline, but that's an example of something that's fine. You're talking about abstract concepts, but actually that is a little concrete, and it's a little gray, but can't assign the new variable, but only with override. Yeah, just name them different names. I say in this lecture question. Make sure that constructor parameter has a different name than the state variable. That's the only time. That should be the only time I believe that comes up is in the boombox constructor. Just name that in the boombox constructor. Name that battery literally anything except battery, and you'll be fine. Schrodinger's battery. Is the battery in the flashlight or out of the flashlight? Schrodinger's battery, the reference is the same both inside the flashlight and outside the flashlight, the returned. Make sure you're checking both references. The same battery is in two different places, inside the flashlight and outside. Can't have that battery twice. It's crazy. How many semesters until my imposter syndrome goes away? It's all of them. This is a big thing in computer science. I only have a few minutes. I won't go on my whole thing, but there are semesters where I still have imposter syndrome. Ethan has a big talk that he gives in his lectures. He's been working as a contractor for, I don't even know how many years. It's got to be at least a decade. And he'll still, when he has a new client negotiating a new contract, he still has those feelings in his head, those thoughts in his head and those feelings that, man, I don't know if I'm qualified for this. I certainly resonate with that. I'll still feel imposter syndrome. Like, how am I here? Like, I shouldn't be here. What's going on? Just, push through. You're fine. Everybody gets that. It's a normal thing. Don't let it discourage you. I don't play D&D, actually. I never got into it. All right, we got to do some 442. Timed out after. If you're working on rhyming dictionary and it timed out, I increased it to 10 minutes for this reason, but if it times out, make sure you're not reading the dictionary 130,000 times. If you're in your all rhymes method, if you're iterating through all of the words in the dictionary, which is about 130,000, if for each word you're reading and parsing the entire dictionary another time, or you're creating a new rhyming dictionary, which is parsing it, that's where you're going to time out. And that's about the only way to time out. So make sure you're only reading that dictionary once each time your program is executed.